Good morning. Welcome to our monthly look at OT networking. It's Mike Lees here, Product Manager, joined again by Ed. Morning, Ed.
Morning, Mike. Hi, everyone.
So, diving in, got quite a bit to do today, Ed, in terms of subjects. So we normally try and keep them to 30 minutes. That's probably as long as I'd like to listen to a webinar for. So we're covering access control lists and firewalls today. So we may just go a little bit over 30 minutes today. Usual format, questions at the end. Thanks for sending the questions through. Most of the questions you're sending are specific to your application, so we take those offline. And, we've started visiting a few sites, helping out for a couple of hours. If you can be flexible on when that visit's required, we can usually do that on a pre-sales basis. There has been a good question submitted today, which we will cover at the end. So on the firewalls, Ed, are we just talking hardware for the firewalls?
I think mostly hardware, yeah. We do touch upon the fact that we can get software firewalls, but I think for most intents and purposes, we're looking at hardware.
Okay. So cutting it brief today, you'll be familiar with this slide, the contradiction that's Ethernet. It's obviously we acknowledge just how tough Ethernet is as a subject, but I'd like to mention today because we're really starting to build on some of the knowledge that we've got on earlier webinars, and I'm conscious that there's new people joining us all the time, Ed, so I guess the answer to that is, as I said, the subject is complex. People can go back and look at the early webinars. They can call us for help, of course, at any time.
Absolutely, yeah.
But the language we'll be using today just build on some of the earlier things. We'll be talking about, OSI models, MAC addresses, VLANs and things. And,
exactly, yeah.
And there's no way around that really, is there?
There's not, no, it's just that little bit of prerequisite knowledge. I think if you've got that, you'll get the most out of these webinars, really.
Okay. We do really try and position the material, though, from an OT engineer in mind, and we'll try and stay true to that. There's lots of videos and webinars online that people can watch about ACLs and firewalls, but yeah, this is really always about our world, if you like.
Yes.
So just to remind ourselves about how we structure the webinars, I've put a little circle around it today just to make it a little bit clearer. So as we said before, the webinars are loosely structured around our 3-day training course. We're on day 3 now, and we've split the security down into 3 different webinars. So today, as I said, access control lists and firewalls, and next time, vulnerabilities and so forth. When we finish going through this, Ed, I think the plan is to then do some deeper dives on certain subjects.
Absolutely, yeah. Go a little bit more in depth in perhaps some of the stuff we went through before. And yeah, I mean, there's a lot of new topics, a lot of stuff we can cover here. So it'd be nice to also perhaps get some requests if people are interested in.
Yeah, the kind of things that people sent through so far is maybe more on addressing.
Yeah, that kind of thing.
That's the favourite, because engineers don't do a lot of addressing, and that's the one that catches most people out, I would say, the addressing and things like setting up subnet masks.
Yes, that kind of thing.
And so forth.
Yeah.
So, access control lists. We talk a lot about demarcation between IT and OT, and access control lists, they are pretty tricky, and I guess they would tend to be within the IT domain. Would you say, Ed?
Yeah, a lot of the time, yeah, you will find them there, but they're becoming, I suppose, more common in OT networks as well, given the fact that security is such a hot topic and an important thing to consider in your OT network. And ACLs are really, the most fundamental and basic way of protecting a network. So they're very important, at least even just to understand the concepts and understand how they work and what they can offer you. Perhaps you don't necessarily need to go down to the level of detail where you can start configuring super advanced ones, but just understanding how they work and where they fit within a network kind of security model.
Okay. A lot of the early work we do with customers in terms of securing networks, the quick fixes that we call it, is quite often things like setting up VLANs, but also setting up ACLs, because these are what I call soft things, where you don't need always to have extra bits of hardware. You can just configure what you've got. So
that's right, yeah, and that's the good thing with ACLs nowadays, is that a lot of devices offer them. Most managed switch as well, even layer 2 ones. You don't have as much flexibility as you would with a layer 3 switch or a firewall, but it's becoming a very common and standard feature on managed hardware. So yeah, definitely worthwhile understanding how they work and where you can apply them.
Okay. You mentioned about layer 2 devices there, and you're talking about layer 3 devices.
Absolutely, yeah. So pretty much any managed switch nowadays will offer some basic access control list functionality. The thing to remember is on layer 2 switches, your basic layer 2 managed switches, most likely you'll only be able to configure ACLs based on MAC addresses, because that's all we're concerned with at layer 2. So they're not quite as common because they're a little bit more fiddly, they're not as flexible, a little bit more administrative work going into creating ACLs based on MAC addresses. MAC addresses are quite, awkward to deal with, so you won't see them as often at layer 2, but it's good to know that we can have them. If we want to protect devices within the same network, we can do that with layer 2 ACLs. But most commonly we'll have them on layer 3 switches, routers, firewalls, anything that kind of acts as a default gateway for clients. That's the most common scenario where you'll find an ACL configured. So just to go through these points here, we'll configure an ACL first, and then we have to apply it to an interface and a direction. So what that means is we create our rule list first, and then we have to decide where we actually want to put that on our device. You can imagine a layer 3 switch or a multi-port router or something like that. We're going to have lots of connections there, lots of interfaces being used. So we have to apply that ACL to an actual interface itself. And we also need to specify whether we're monitoring and inspecting traffic coming into the interface or going out of it. So there's a bit of planning that's involved into that, because writing the ACL is one thing, putting it in the most efficient part of a network and obviously getting the direction right is quite important to make sure your ACL is running in the most efficient way, and also more importantly B, to make sure that you're either not inadvertently breaking other connectivity and also that you're actually protecting it where you should be and not putting it somewhere where it's not going to be doing anything and it was a kind of waste of time writing the ACL in the first place. So generally speaking, and this is applicable mainly in the Cisco world, we have basic and advanced ACLs. Basic ones only allow us to filter based on the source address, whether that's an IP address or a MAC address. We could also do it based on an entire network, a source IP network, but the important thing to remember is it's only on the source address. So a basic ACL in the Cisco world, we cannot filter by the destination address, we can't filter by protocol port, that kind of thing. So they are very basic, which is obviously good in that they're easy to administer, there's potentially less to go wrong, but obviously they're not as flexible. We're limited as to what we can do with them. And obviously the opposite of the basic ones, we've got the advanced or the extended ones, as they're called in the Cisco world, and with them we can filter on absolutely everything. So source address, destination addresses, protocols, port numbers, there's no real limit as to what we can filter on. So obviously advanced ones are a way to go if you want total control, total flexibility. They obviously do occur that, extra design required and a little bit more thought into where they need to go.
I guess most ACLs that people are going to find configured, they will be of the advanced type rather than the basic. Most
likely, yeah, and some vendors won't even have this concept of basic and advanced. I think Hirschman, for example, you're just given the ability to put in an ACL, and by default you'll get all the options of an advanced one that you would in the Cisco world. So some vendors follow this, others don't, and obviously Cisco and Hirschman are the two big different ones here. So just some more kind of basics, more best practices, I suppose, for ACLs. So the ACL will work on the concept of you'll have a bunch of rules that have been configured in there, and when a packet comes in, that ACL is processed in order. So if a packet comes in, we inspect it, we look at the first rule of the ACL, we see if it's a match or not. If it's not, we go to the next one, and we keep doing that until we find a match. If we find a match, then we either permit or deny, depending on what we've written in the rule, and at that point the ACL is no longer processed. So once there's a match, that's it. The ACL is no longer processed, no more rules are applied, we've already decided what we're doing with the packet. So the important thing to remember about is this really is applicable to all vendors. It's just the basic design of how ACLs work, but at the end of your set of rules, you'll have an implicit deny all rule. So it's like an invisible rule at the end of your rules that says, right, drop the packet. So if it hasn't been a match, if you've written your ACL, packets come in, there's no match on any of the rules you've written, by default that will just get dropped at the end.
So we could lose traffic that we want if we don't get it right.
Exactly. So that is such an important thing to remember, that if there is no match, that packet will get dropped unless you say otherwise. So we can work our way around that by creating a rule at the very end to say allow everything, and then we don't have to worry about this implicit denial rule. But it depends a lot on how you're creating your ACLs. There's kind of two ways you can do them. You can say, I want to deny specific things but allow everything else, and then you'd have your allow all rule at the bottom. Or you might say, well, I only want to allow these specific, sets of traffic, and let's drop everything else at the end. So there's kind of two ways to do them, depending on how much security you want and that kind of thing. And really, there's no right or wrong way. It's just understanding how they work and ensuring that you've written them correctly. So moving on from that, some vendors, and I know Cisco do this, I think that Checkpoint do this as well, and probably a lot of others, they offer kind of time of day based ACLs. So these are ACLs that only kick in certain hours of the day. And I suppose that a practical use for that could be, let's say you've got an operator working on the night shift, you don't want him to be able to, browse the internet, that kind of thing. We could put in an ACL after 5 p.m. or whenever his shift is to, deny outgoing traffic. That's just a basic example of where we might use a time of day based ACL. The next point is probably one of the most important ones, but also a little bit tricky to sometimes get your head around. I know it took me a while, and this is what they kind of teach you in the Cisco world, mainly because they have this clear difference between basic and advanced ACLs. But essentially, they say that basic ACLs should be applied as close to the destination as possible. So if you remember with basic ACLs, we can only filter based on the source address. That's all we've got to go on. So the reason we want to put them as close to the destination as possible is we don't want to inadvertently deny traffic to other, legitimate parts of the network, but we want to allow that source too. So if we were to apply that rule too close to the source, we would deny the source from communicating with anything, and that's obviously not what we want to do. We may just want one network to not be able to talk to a SCADA LAN or a server LAN that houses a lot of critical servers. So we'd put that as close to that server network as possible. Advanced, on the other hand, because we can filter based on absolutely anything, port numbers, destination, IP addresses and networks, that kind of thing, then ideally what we want to do is have that as close to the source as possible to stop us from wasting resources on a switch. And what I mean by that is, if we've already decided, right, we'll write this advanced ACL and we want to deny traffic to a certain destination address based on a port number, maybe we're stopping a bunch of engineering workstations from accessing the SQL server, something really critical. We don't want to put that close to the destination, because what will happen is, although it will work just as well as placing it close to the source, what we're inadvertently doing is wasting resources on the switch. So the switch is inspecting the packet, there's no ACL applied to the incoming interface, it's switching it or routing it to the other interface and dropping it then. So we've wasted resources on the switch, processing the packet, which it should have dropped in the first place anyway. And that's kind of where this rule of thumb comes into the difference between the basic and the advanced ones.
I think you said on the training course, this takes a bit of explaining and people to get their head around, but it's a great rule of thumb, isn't it?
Absolutely, yeah. Just to make your security rules as efficient as they can be, really.
I think we've got some examples now.
Okay, so here's an example, a basic one. And this syntax in this box underneath is how it would look in the Cisco world. So this is the command line Cisco rules for an ACL. So obviously on a Hirschman switch or something like that, you'd perhaps have a nice GUI and you wouldn't have to worry about all these commands. So don't let them put you off too much. I'll just briefly explain what's going on here. We've just written a very basic ACL with a single rule. So we've said access list number 1. We want to permit the IP address 10.10.1.100, and that is PC1 on the left-hand side there. And we are applying that to the GI0/3 interface, which is the interface connected to the server LAN, where you can see that web server on the right-hand side. So what we're essentially doing there is saying, right, PC1, we're allowing that to talk to the web server. Now, if PC2 is attempting to connect to the web server, there we get denied because of this implicit denial rule at the end. So you can see that it's not actually there in the syntax and we can't see it. We just have to remember that it's there. It's always there unless we say otherwise. So that's as basic as an ACL can really get. We're permitting a single IP address and applying it to one interface. We're saying, yeah, allow this one through, and because of the denial rule, anything else is denied. Okay, so this one, very similar to before, except instead of just allowing one PC, let's say we wanted to allow an entire network, an entire LAN. In this case, we're saying it's an engineering LAN, so it's a trusted LAN. We know the devices we've got on there. We know the users using it. We want to trust that entire engineering LAN to talk to the web server. So essentially, we've just used these wildcards. Now, these differ from vendor to vendor. So there's no kind of fixed rule with these. And all it's basically doing is representing an entire network as opposed to a single device. So here we've said 10.10.1.0, and we've actually got a reverse subnet mask.
Like a subnet mask, but
it's flipped over, exactly. I do have an answer as to why Cisco did that. I just can't remember it off the top of my head. And to be honest, it doesn't help. It doesn't make it any easier to learn ACLs in the Cisco world, because this kind of goes against what you'll have previously learned with subnet masking and that kind of thing. With that being said, other vendors, for example, Hirschman, they might make it a little bit easier to represent a network. You'll use question marks instead. It would be 10.10.1. Which says that last octet can be anything, representing that entire subnet. So it makes it a little bit easier. But essentially, that's what we're doing with this ACL. We're saying, right, permit that entire LAN, and once again, because of the denial rule at the bottom, PC2 still can't touch a web server.
Right, that looks a bit hairy to me.
This one is a bit scary, and yeah, so try not to get too concerned with the CLI stuff at the bottom. So in this example, we've got PC2. And PC2, which is 10.10.3.1.100, that's in the top left corner. Those first two rules then in that rectangle there, access list 101, we want to permit TCP from, so the syntax starts with the source first, destination after. So we're saying, right, permit it from PC2, and our destination is 10.10.2.100, which is a web server. And those ports, those numbers at the end, so we've got EQ80 and EQ443, they're the standard HTTP and HTTPS ports. So all we're doing there is saying, right, PC2 can talk to the web server over HTTP or HTTPS. And we're applying that then as close to the source as possible. So what we've done there is we've applied it to the 0/2 interface. As soon as that packet comes in, we're looking and we're saying, right, is PC2 trying to talk to the web server? If so, allow it. If not, deny it. So this could be a very basic PC somewhere in an unsecure location. We literally want to lock it down so it can just access. It might be a reporting service, some kind of SCADA monitoring service or something. We want it to be able to view that, but nothing else. It's like a view only. So we've really locked these rules down. We're saying you can talk to the web server, you can't talk to anything else. The other thing we've done here is we've also created a second ACL to allow 10.10.1.0, and that's the engineering LAN. And we've said permit IP, which is anything. So we're essentially saying here the whole of the engineering LAN can talk to everything on the server LAN 10.10.2.0. So we've put some levels of trust in here. We're saying engineering LAN, that's fine, that can talk to everything on the web server. But this PC2 in another network, that might be in a lobby somewhere, it might be somewhere untrusted, anyone comes along and is able to access it. So we've said with that, right, that can only talk to web server, nothing else. So the syntax is a little bit scary, I do admit, but as long as the hardest part with ACL is normally understanding your requirements, knowing what you want to allow and what you don't want to allow. and if there's going to be any implications to that. Are you inadvertently going to, deny legitimate access you need somewhere? So the hardest part is mapping out what you want to allow and what you don't. The syntax is always the same, and obviously it does differ from vendor to vendor, but once you've decided on your rules, writing the syntax isn't too bad after you've done the first few. You soon understand how it works, how it's structured, and that kind of thing.
You've got one further example.
We do have one more advanced, yeah.
What's the difference on this one, Ed, than the previous one?
So the only difference here, so if we look at the first two rules at the top are exactly the same as before. We're saying PC2 can talk to the web server. But we're also saying here that PC2 can also talk to the engineering LAN. So we want to allow PC2 to talk to web server, nothing else in the server LAN, but we also want to give it access to the engineering LAN. There may be some devices on there it needs to talk to, that kind of thing. And the only difference that we've done at the bottom, so if we look at the second access controller, say 102, we are denying the entire engineering LAN there, so 10.10.1.0, that's the whole of the LAN, engineering LAN. We're denying it to talk to the database server. So we're essentially saying anything in the engineering LAN cannot talk to that database server. That might be critical, it might be owned by another vendor. We might not want anyone in the engineering LAN going anywhere near that because it's got some real critical data on that they shouldn't be messing with. So we've essentially said anything from that LAN cannot talk to anything on that database server. Now, because we've done this in a slightly different way, as I said before, there's a couple of ways to write ACLs. You deny everything and allow some at the end, or you allow things you want and let the implicit rule deny at the end. What we've said here is we just want to deny it to the database server, but we've put this permit IP any rule underneath that. So that says that absolutely anything from any source to any destination is allowed. But because, as I said at the start, because of ordering of ACLs, how it works, that rule at the top takes precedence. So the first thing it will do is check if we're talking to a database server. If it doesn't match that, we're allowing whatever else it may be. So it's just one single rule to deny access to a single device.
It's unlikely that anybody listening today who didn't know ACLs before, they're not going to suddenly dash off and start writing these things.
Not, no, absolutely not.
But it's all about having the awareness of what's possible.
Exactly, yeah.
Would you agree, Ed? I mean, ACL should be a fundamental part of cyber security.
Absolutely, yeah. And yeah, that's right, yeah. And even basic ones, you don't have to write super convoluted ACLs and create an administrative headache going forward. Even some basic ones put in the right places can help you a lot. But it really is, and as I said before, the hardest part is knowing what devices need to legitimately talk to others. And if they don't need to talk to others, then those are places where you should be putting rules in. If that has no legitimate reason to talk to another device or another network, then we should be denying that. Just kind of basic security 101, really.
Now, we come across situations on sites where the OT engineers don't own the layer 3 devices.
Yes.
So what's the implications there? By layer 3 devices, I'm implying that that's where most of these ACLs will be set up.
Generally speaking, they are, yeah. And there's a couple ways round that. There are scenarios where we may want to use a transparent firewall,
or even talk to the IT department.
I mean, yeah, you probably won't get very far, but yeah. In an ideal world, you'd have a nice discussion with the IT department, tell them what you want to implement, but in my experience...
And having an understanding of ACLs would allow you then to have that conversation.
Absolutely, yeah, that's right. I mean, if you can fully explain your requirements to them, then there's a good chance that they'll work with you and get these kind of put in. If obviously you can't do that and there's just kind of no way to modify anything on those layer 3 devices that aren't in your custody, then the good news is there are still some scenarios where we can retrofit devices kind of in transparent mode, which we'll move on to.
That wasn't meant to be a lead into the next slide, but it worked out quite well.
Very well.
I guess when people are thinking about security, they don't think ACLs, top of mind, firewalls. Yeah.
Absolutely, yeah. But with firewalls, the most common feature on a firewall is ACL, so it's good to know that they go hand in hand. So They do ACLs, and that's a core of their kind of functionality, the main role of them in the network, but they also do a lot of other things, especially nowadays, you know, IPS and IDS systems, so intrusion prevention and intrusion detection systems. So we'll have a little look at those as well. But maybe if we just start with kind of different types of firewalls and how they work. So they can come in software and hardware forms, and a lot of layer 3 devices will now offer firewall functionality, but also firewalls nowadays will offer layer 3 functionality. So it used to be that you'd have a router, you'd have a firewall, and now a lot of devices are combining these features together. So for example, in the Hirschman world, you've got the Eagle 30, which is you know, a router and a firewall. It does layer 3, it does ACLs, there's other firewall functionality. So it's a single device essentially to provide routing for networks and provide security.
So we've seen a blurring of the lines really. I mean, in the very first webinar we talked about this does this, this does this, but
yes. The technology is moving fast in the networking world, and yeah, now you'll have devices that can do everything. And the thing is that these devices as well will do general layer 2 switching as well. So it is becoming to the point where we're just going to be combining this functionality into, you know, a big device, one big mega device almost. I mean, we did briefly mention software before, but really we're talking things like Windows Firewall and that kind of thing, and other, you know, Komodo software firewalls, things like that. And they have their use in certain scenarios, but really hardware firewalls, we want to protect the entire network. There might be scenarios where we need to protect individual devices, but generally speaking, we're looking at the whole picture, and that's why we want to use a hardware firewall. So they're used to protect different areas of a network, and most commonly you might see them in the DMZ zone. So you might see one after your internet connection before it hits any rest of the network, a perimeter firewall perhaps, if you will. But you can also have them further down in the network, and you can have them as low down as, you know, where your PLCs are. We can, and obviously Hirschman offer these Tofino firewalls, which are you know, very, I say basic firewalls, but they're intended for a specific purpose to protect a small ring of devices, if you will, a small ring of PLCs. So we can have them top to bottom, but generally speaking, we will see them protecting multiple networks, and because of that, we might have them further up the chain, if you will.
A lot of the projects we've done, Ed, on the firewalls deeper down have quite often been on legacy projects.
Generally speaking, yeah.
Like you say, some XP machines.
Yes.
That the customers can't
touch.
They can't touch, they can't upgrade them, and therefore we find that firewalling is a good solution.
Absolutely, yeah, yeah.
Lower down.
Exactly, because sometimes it's just not feasible to replace legacy kit, that, you know, the headache and the cost and the time involved.
Earlier on, when we can't get access to the layer 3 devices.
Exactly, yeah.
We might do more firewalling, so it might alter the balance of the security.
Yes, yes, strategy. Absolutely. I mean, it's just worth noting that it's good to plan the kind of firewall you want and where you're going to put it. And obviously, as you know, we've had scenarios where we've had firewalls that weren't up to the job, they didn't do what we wanted them to do. So it's good to understand what firewall you're looking at and the features it offers and how that's going to sit in your network. If a firewall only does rooted mode and not transparent mode, for example, and you've got no access to your layer 3 stuff, then you're not going to get anywhere. It's not going to help you at all.
I think the next slide is actually going into more detail now.
Exactly, yeah. So the rooted mode firewalls, quite simply, imagine them just as your routers. So if you've got two different networks and you had a firewall that does rooted mode, then you could just have that firewall as your default gateway for all your clients on both networks. So what that basically is doing is it's ensuring that any traffic that passes from LAN to LAN, it has to go through that firewall because that's the default gateway. There's no other way it can go through. You know, it has to be inspected by the firewall before it decides to route that packet onto the other network. And this is quite common, really. This is one of the most common types of firewall functionality and applications you'll see for it, is using it as your default gateway for your clients. And you will see these a lot in the kind of a DMZ zone, distribution zone, somewhere a little bit higher up in the network where we're essentially, you know, linking different networks together. This is one of the most common types of firewall, and I suppose in a way it's perhaps one of the easier ones to configure as well. We've got clear boundaries between networks. And in this scenario here, you can imagine there we might just have two interfaces, one going into LAN 1 switch, another going into LAN 2 switch. We've got a nice, easy setup there. And that's a very common scenario you'll see with a routed mode firewall.
I'll pick up on that, because you say it's easy, but when you're retrofitting.
Yes, when you're retrofitting then.
Why is retrofitting harder?
I mean, I suppose there's a couple of things. When you retrofit, if you were to retrofit a routed mode firewall, you've got to ensure that you're configuring the interfaces exactly with the same IP address as your current default gateways. If not, you've got the big task of readdressing a load of clients. Yeah.
And if there is no default gateway, then you add in an extra device, and then you could be faced with reconfiguring.
Yes. You could have, exactly, yeah, which can be a real nightmare when you've got PLCs, workstations, HMIs, things like that. And there's been a lot of times where if you have to reconfigure legacy kit and there's no one around who can do it, or no one's got a clue what how his kit's even configured, I've seen that a lot as well. So it can be a bit of an arduous task doing that. And in an ideal world, if you've got an existing layer 3 gateway and you're replacing it, you'll keep the IP addresses the same. Then your clients will just work as normal. You haven't got to do any of that. Okay. So this is the transparent mode. And essentially what this is doing is it's based on the principle that we're inspecting traffic that is physically coming through the device, through the firewall. So if you look on the diagram on the left-hand side there, imagine we've got our network there at the bottom. We've got two LANs, we've got VLANs and whatnot on that switch. But if we want to talk from LAN to LAN, that has to go up to that layer 3 switch, because that's the default gateway for both VLANs. So what we've done there, imagine that we don't have any access to that layer 3 switch. We're not allowed to touch it, can't reconfigure it, things like that. What we've done here is we've physically retrofitted a device between the switch, the core switch, and the layer 3 switch. So there's only one way that traffic can physically pass through now, and that is through that firewall. So although the clients still see the layer 3 switch as a gateway, the traffic is physically passing through that firewall. It's going in one interface, it's going out the other. And it's at that point we can then create our ACLs. We don't have to rely on the clients being having the firewall as the default gateway. We can just write our ACLs now, knowing that traffic has to physically go through it. So they're great for retrofit scenarios, because if you can't touch your layer 3 stuff, or you're not comfortable with it, or whatever number of reasons there may be, we can just physically fit one of these transparent mode ones and have all the same firewall functionality that we would have in a routed mode one.
Okay. So in terms of retrofit, you could add a firewall. Do they have learning modes that would make it?
Some do, yes. I know in the Hirschman world they make it quite easy for you, at least easier. And they do, yeah, they have a learning mode. So you essentially, it's a transparent device when you put it in learning mode. It passes all traffic through, doesn't filter anything, but while it's doing that, it's inspecting all the connections. And after a number of hours, a number of days, or however long it may be, you've essentially got a big list of rules there, almost a baseline of a traffic that's passing through it. Now, there may still be some work involved there to kind of cut out the illegitimate connections you've got there, but it's helped you immensely with port numbers and things like that, the fundamentals of writing your ACLs. And it can be a lot of work involved in trying to find out things like port numbers, and some software packages use a great deal of them, and it can be a right headache trying to understand which ones they need. And that's where learning mode comes in. It does a lot of the hard work for you.
That's routed and transparent mode firewalls.
Yeah. So DPI, then deep packet inspection, this is quite a common feature now on a lot of firewalls, particularly in kind of a Cisco world, and Checkpoint, Juniper, those kind of vendors. And it's essentially a way of inspecting the contents of a packet. So with a normal ACL, we are just filtering based on IP addresses, port numbers, that kind of thing, which is all good and well. However, the problem there is, imagine we have to write an ACL, and we have to allow traffic to a web server because, we need clients to be able to read what's on the web server. The problem there is, with a traditional ACL, is a traditional ACL won't care what's in that packet. So when we're talking to the web server, it just looks at the ACL, sees that it's allowed and sends it through. But we could have all kinds of malformed and malicious data in that packet trying to exploit the web server. And a traditional firewall ACLs won't do a thing about it, won't be able to, it's not intelligent enough to inspect it. And that's where deep packet inspection comes in. So it takes a look at the packet, takes a look at the contents, and based on a signature list or kind of heuristics type technology, it will decide whether that payload is legitimate or not, and it will pass it through or drop it. So it's taking ACLs a step further, and we've got it at the top, but normal firewalls work on stateful inspection. So that's just essentially to keep track of the legitimate connections that are coming in. And that's the only way it can work with a traditional firewall. So as I say, it won't look at the contents of a packet. And that's the next step now that malicious users and hackers and people with ill intent are doing, that they know that the only way around and exploiting firewalls is through the application layer. So through the data, but the legitimate data streams they can send to a web server, they're looking at ways to exploit that now. And that's where deep packet inspection comes in.
If you're talking application layer, is there a performance consideration now? I mean, I guess you're opening packets, looking in detail.
Yes, yes. To an extent, there is, but a lot of the kind of firewalls with this functionality are doing things at line speed now, which essentially means there's kind of no latency. So the rules and the DPI functionality is kind of put into an ASIC chip. So there's no kind of, in a lot of them anyway, and there's no software lookup to delay things. So it's not as much of a concern as it used to be. Depending on, there's no right or wrong answer to it, but depending on the size of the network, the amount of requests coming in, generally speaking, you won't see too much of a delay. If you've got a line speed device, at least, anyway, and most modern ones are nowadays.
So line speed means basically that the firewall isn't impacting the
Yes.
speed of the network.
Exactly. It's all done in hardware, so there's no software, there's no rules to look for in software that would incur delays. So denial of service is another big kind of topic in the cybersecurity world, and it's a denial of service attack is essentially where a hacker or a malicious user will attempt to overwhelm a device in the network, or just overwhelm a network in general, to the point where it can no longer process legitimate requests, and that obviously disrupts connectivity with genuine users. And that can be a disaster if you've got it in a key part of your plant or a key area of a network, and if you've got a denial of service attack going on there and legitimate requests can't come through, you may have PLCs that can't talk to each other, then it becomes a bit of a nightmare. So a lot of firewalls nowadays will also offer denial of service protection. So they will have thresholds for connection types and things like that. They'll be able to say, okay, if we've just had 100 connections fly in a millisecond, there's something not right here, and when you start throttling them back.
You got an example?
I have a nice little example here, yeah. So the guy with the sunglasses on the top left is our hacker, and we've got our user underneath. So what's happening here is the hacker is sending, let's take TCP as an example. So with TCP, we have to establish a connection before we can send data. So we've got this SYN packet going from left to right, this SYN acknowledgement packet going from right to left, and then to complete the connection, the user on the left would send another ACK packet. And at that point, we're ready to send data, we've established a connection. And in this attack, what's happening is the user's sending lots of synchronization packets. It's trying to establish lots of connections. The device on the right is sending these SYN ACKs back, saying, okay, yeah, I'm ready to accept, just send me your final acknowledgement, but the user never does. So these half-open connections are residing in memory on your device, whether that will be a legacy switch, a file, or whatever. And the more of these that we throw at this device, these half-open connections, there will eventually come to a point where the memory has been consumed, the maximum number of connections has been reached, and we've got this user on the bottom left there, sent the SYN packet, got nothing back. And that's a common denial of service type attack, and that can happen in a LAN, it can happen over the internet as well. You have these distributed denial of service attacks where a hacker will have custody of hundreds or maybe thousands of infected machines around the world, and they will send this very similar attack to this to a public server, web server, or whatever, and you know, with the intention of bringing it down and preventing legitimate users from being able to connect.
The protection is a threshold value in there?
Exactly, yeah. With denial of service features on a firewall, they're normally quite easy in the way that you just enable it. You enable it and it does the rest. Because with a firewall that had denial of service protection, you would get so many of these synchronization packets coming in, and it would eventually get to a point it's like, right, well, you know, I'm not going to accept any more from this user. And it will attempt to differentiate between legitimate ones and non-legitimate ones, and some vendors do that better than others. And it's like a constant battle really between vendors updating their functionality and their firmware to cope with this, and hackers trying to find ways to exploit it, I suppose.
Thanks. Our final slide today on IPS and IDS, it's the final slide in one slide, but it's a massive subject.
It is, yeah.
Itself, isn't it? And it's, you know, SolutionsPT, we're doing a lot of work on these systems at the moment.
Yes.
How I mean, they mentioned here that they use deep packet inspection. When does it become an IDS or an IPS system rather than just a deep packet inspection firewall, or is it a bit blurred?
It's a bit blurred because there's, you know, a lot of crossover here. Some Cisco firewalls will offer deep packet inspection and IDS and IPS functionality. Having said that, you can get some devices and or software that do strictly just IDS through the use of deep packet inspection. So there's a bit of blur there. And really in the future, these will be more kind of features on a firewall, if nothing else. But essentially, the difference really between the two, clues in the name, one will actively prevent it, and the other one will just detect it and, you know, be set up to alert an administrator. And they do work on the principle of using deep packet inspection, but also using like a baseline of traffic. So you may run like an IDS system for a day, a week, or however long to get a picture of how your network looks, get a picture of bandwidth being used, the amount of connections for various protocols and applications coming in and out, that kind of thing. And once you've got that baseline, then an IDS is more efficient in its ability to detect when something unusual is happening. Loads of connections coming in, lots of SNMP traffic, for example, where someone's trying to sniff a network and start to discover stuff about your devices. And obviously with an IDS system, they will alert a user. They may email a network administrator or send you a text or something like that and say, you know, there could be some potential malicious activity going on here. And obviously a prevention system will just actively start making a decision on whether it should allow or drop packets. And I think the key difference with it is that detection systems, you know, they will never drop traffic, so there's no concern for legitimate requests being dropped because your IDS wasn't quite configured right. And obviously there are scenarios where an IPS may drop traffic, but it shouldn't have done just because things don't quite look right to it. So obviously they're not 100% foolproof, but really that's the difference between the two. The IDS is almost read-only, if you will, but it will just keep you informed if anything weird going on in your network.
And I suspect we'll be revisiting this at some point in the future.
It's a big topic, yeah.
Certainly our experience that beyond firewalls, IDS systems are what most people are looking at. And
yes.
At SolutionsPT, we've been piloting 2 or 3 systems over the last few months and working with some customers, so we'll be happy to share data on that and which one we're going to go for. But yeah, there's certainly a lot more of this in the future. So thanks, Ed.
No problem.
So next time, final one on the kind of the official thing, common vulnerabilities. Just running through.
Yeah, just looking at some kind of common vulnerabilities that you may find in your network, some common ways that a hacker or malicious user may use to compromise things.
I think that'll be another great subject. Thanks, Ed.
Really, no problem.
So, in terms of questions, I don't think any questions have come in, have they, during? I'll just run through this question that I mentioned earlier on, and it's actually really relevant to what we've just been talking about, Ed. And the question is, in your experience, what is the biggest challenge to implementing traffic filtering or IDS in existing industrial networks? Now, I know you've got some views on that, and so have I, Ed. In terms of the IDS, you mentioned baselining, which is great. The baselining works fine. What I found in the projects I've been involved with is just the sheer amount of data that's produced by these IDS systems. It's almost overwhelming for the OT department. People start off with good intentions, managing the reports and the data, and they just fall into disuse.
Yeah.
And I think that's the biggest challenge, and I think the way that we're looking to help customers with that is probably, it almost needs a managed service approach.
Yeah.
So IDS looks great, makes a great sales brochure, but they do kick out quite a bit of stuff, even with very effective baselining.
Absolutely, yeah, yeah.
What are your thoughts, Ed, on that?
Yeah, I mean, particularly on bigger networks, there's always a lot going on when you've got a lot of functionality in your network, a lot of different devices, a lot of communications between different networks. There's so much going on, and IDS, it's all dependent on how well the IDS is configured and the kind of monitoring it's been set up for. But yeah, you're absolutely right, Mike. They kick out so much data that sometimes it's hard to differentiate between legitimate malicious attempts and normal kind of day-to-day Ethernet chatter and that kind of thing. So really, yeah, the managed service approach is generally the best way to handle it. Otherwise, it can consume a lot of your time and resources going through log files and constantly being alerted to stuff that perhaps isn't a real threat, but you may have just had an engineer on site who's loaded up a piece of SNMP software, something like that.
Another way that we are approaching this is, rather than have a managed service, we're working with some customers trialling sort of a quarterly review where we'd go in, do an IDS report. It's possible to capture the data using a PCAP file.
Yeah.
So it can be done offline, so we can then go back and advise. That might be more realistic. So the message is really we don't have a silver bullet today to say that's how to do it, but that's how we're approaching it, and we'll be certainly feeding back our experiences. In terms of sort of general traffic filtering, I think the biggest challenge we've come across there is getting the right firewall, especially in retrofit situations. And then
absolutely,
you mentioned the learning mode earlier on, so we don't disrupt things.
That's right, yeah.
And testing as much as possible.
Testing, and then testing some more, yeah, because you only have to miss out one rule, one port to one device, and you can, break some serious functionality in your SCADA network. So a lot of testing has to go into it.
It's a good question, because to me it just typifies the challenge that we're all hearing lots about all these fantastic things you can do, but the practicalities of implementation are not always that simple.
No, absolutely.
Okay, thanks very much. Right, well that brings to a conclusion today's webinar. I hope you enjoyed it and got something out of it. As ever, the webinars will be available for download. Myself and Ed available online, or you can call us if you've got any questions. As you know, we work with both Hirschman and Cisco, happy to work to assist on design and audits. As I mentioned at the start, we are starting to getting requests for us popping out and looking at customers' problems, which we're happy to do, especially if it can be flexible on timescales and so forth. We're trying to do this on a pre-sales basis. So it just remains for me to say thanks very much, Ed.
No problem, Mike.
And back here in 1 month. Thank you very much. Bye-bye.
Bye-bye.